All right, let's dive right in. We are going to tackle one of the biggest, most persistent myths in all of programming. It's this one single idea that honestly stops so many creative, brilliant people from ever writing their first line of code. It's a huge misunderstanding, and today we are going to set the record straight once and for all. Yeah, this one. I'm sure you've heard it before. Maybe you've even thought it yourself. This one sentence has probably gatekept the world of coding more than any tricky algorithm ever could. It's the story we've been told, the story we tell ourselves, but today we're going to find out if that story holds any water. So let's just ask the question, point blank. Do you really need to be a math whiz to build the next amazing app, or design a beautiful website, or create a mind-blowing game? Or is there a different skill, a more crucial one, that's been hiding in plain sight this whole time? Let's find out. Okay, so here's our game plan. First, we're going to dismantle that math genius myth. Then we'll get into why logic is the real heart of coding. After that, I'll give you a brand new coding toolkit. We'll even see how this mouth pops up in your everyday social media scroll. And finally, we'll reframe all of this to see coding for what it is, the language of creation. First up, let's bust this myth wide open. The anxiety that people feel around math and programming, it's totally real. But, it's almost always based on a completely false premise of what coding actually demands from you. And here it is. This is the big disconnect. The myth would have you believe you need to be scribbling calculus proofs just to write a simple script. But the reality, it's so much more accessible. Coding is really less about being a human calculator and way more about being a creative problem solver. It's about thinking logically and learning how to break a giant, scary problem down into small, bite-sized pieces. So if it's not about crunching complex numbers, what is it about? Well, this is where we get to the real core of it all. While you don't need all of math, the actual foundation of coding, the way a computer thinks, is built on the principles of mathematical logic. Think about any app you use. Fundamentally, all it's doing is following a pre-written set of instructions. We call these instructions algorithms, but honestly, you can just think of them as a recipe. A very precise, logical recipe that tells the computer exactly what to do step by step to get a specific result. And it really is that simple. If the user clicks the buy button, then add the item to the cart. That's it. That's a logical decision, and that kind of thinking comes directly from the world of mathematics. Every single program you've ever used is just built on a massive, interconnected chain of these simple if-then decisions. And this, of course, leads us to the most important question of all. If we're tossing out the idea that you need to be a calculus expert, what should you focus on instead? What are the actual practical math concepts that will give you a serious advantage as a programmer today? Okay, welcome to your new coding toolkit. Seriously, you can forget about those dusty old calculus textbooks for a minute. We're going to zero in on 3 specific areas of math that are incredibly powerful for anyone looking to build modern software. Now here's the key. You do not need to become a world-class expert in all of mathematics. Not at all. By just getting comfortable with these 3 core concepts, you'll be set up for some of the most exciting and in-demand fields in all of tech. First on our list is linear algebra. I know, the name sounds a little intimidating, right? But it's basically the math of grids and coordinates. If you've ever played a video game and wondered how a character moves so smoothly in a 3D world, well, that's linear algebra making it happen. It's all about using what we call vectors and matrices to move and change objects in a virtual space. Next up, we've got probability and statistics. This is the engine that runs our entire data-driven world. Ever wonder how a system like Netflix learns what movies you like? It's using statistics to find patterns in data and probability to predict what you'll want to watch next. This is absolutely critical for data science, machine learning, and AI. And finally, we have graph theory. I know we're not talking about the bar graphs you made in science class. This is the math of connections. It studies how networks are formed, whether that's a network of your friends on Facebook or the network of roads on Google Maps. It's the secret sauce behind everything from friend suggestions to finding the fastest route to get to work. All right, that's the theory. But let's see this stuff in action, because these aren't just abstract ideas you learn in a classroom. They are the invisible engines running inside the apps you're probably using every single day. I mean, think about it. You are already interacting with your new toolkit every time you scroll. When Instagram decides which photo to show you first, that's statistics. When Facebook suggests a new person you might know, that's graph theory mapping out your social web. And yeah, every time you explore a 3D world in a game, you're experiencing the power of linear algebra. It's literally all around us. Here's a super simplified way to think about how a platform like Instagram might do this. A like might be worth half a point. A comment might be worth a bit less, and a share a bit less than that. The platform then uses a basic statistical formula to add up those weights, and that final score helps decide where a post appears in your feed. It's just practical math happening right on your phone.
So let's bring this all home. We've busted the myth, we've figured out that logic is the real skill here, and we've built a new toolkit. The last step is to completely change our perspective on what math really is for a programmer.
And here's the bottom line. The absolute biggest mistake any beginner can make isn't a misplaced comma in their code. It's believing that myth, that they can't code because they were bad at math in school. The real wall isn't your math ability, it's the myth itself. Okay, so let's recap the big stuff. Coding is really just applied logic, not complex calculation. You want to focus on which math actually matters. Linear algebra for graphics and games, statistics for data, and graph theory for networks. And remember, you're already seeing these concepts at work every day. You don't need to be a genius. You just need to be a curious problem solver. So I want to leave you with this one last thought. Math isn't some scary gatekeeper trying to keep you out of coding. It's a foundational, universal language. It's the language that describes our physical world, and it's the only language we have to describe, create, and build the virtual worlds of the future. The only question left is, what world do you want to build?